friends. So today the topic which we are going to start is chapter 2 of geometry standard 10th. I know that our last chapter was mensuration, and I had taken many parts of it, so you can go and watch it. So we'll be beginning with another lesson. It's the Pythagoras theorem. It is also a very important lesson. In 9th standard you just had a single formula related to Pythagoras theorem, but in 10th standard you have an entire lesson based on this formula. So basically it is divided into almost 3 to 4 parts. We'll be first understanding the basics, then we'll go to the advanced level. So let us begin. So first of all, what we are going to see is the definition of Pythagoras theorem, or kind of understand the Pythagoras theorem. So Pythagoras theorem means that in a right angle triangle, ABC is a right angle triangle, the sequence of hypotenuse is equal to the square of the remaining side. First of all, I would like to tell you that AC is regarded as the hypotenuse. You may have learnt in 9th standard, but just for reference I told you that AC is the hypotenuse. So what here it is given is what is given here is that the sequence of hypotenuse is equal to the square of the remaining side, which means that AC square equals to AB square plus BC square. It means that the square of the total measure of AC equals to the square of total measure of AB plus square of total measure of BC. Now let us see that in triangle ABC, measure angle B equals to 90 degree. Therefore AC square equals to AB square plus BC square. Now I would like to tell you one thing, that it is only possible, means AC is only considered to be the hypotenuse only when this angle ABC is 90 degree. Means if there's any angle 90 degree in a triangle, then we can say that it is a right angle triangle, and it is not prohibited to use Pythagoras theorem. Now let us see the converse of Pythagoras theorem. So basically, converse of Pythagoras theorem means that in a triangle, if the square of one side is equal to the sum of the squares of the remaining sides, then the triangle is a right angle triangle. What just I told you, it's the converse of that. Now one thing you will have to notice, that in the Pythagoras theorem I told you that if one angle is 90 degree, then we can say that AC square equals to AB square plus BC square. But in converse of Pythagoras theorem, what happens is that if angle ABC, if AC square equals to AB square plus BC square, then only we can say that measure angle B is 90 degree. Means that's the converse part, which means that in the Pythagoras theorem we are given this and we have to prove this, and in converse of Pythagoras theorem we are given this and we have to prove this. Now let us see Pythagorean triplet. So what is Pythagorean triplet? In a triplet of natural numbers, see one more thing, there's only triplet of natural numbers and not of integers. So in a triplet of natural numbers, if the sequence of the largest number is equal to the sum of the square of the remaining two numbers, then the triplet is called a Pythagorean triplet. Now I'll explain it to you in easy words. So it means that in a triplet, see one more thing I would like to tell you, that a triplet means a combination or a group of just 3 numbers. They can be any number, they can be 100, 200, 300. See one group I have taken here, which is 11, 60, 61. So what they want to tell, that we can prove this to be a Pythagorean triplet only when the largest number's square is equal to the square, means addition of squares of these two numbers. See for example, here we'll consider 11 to be A, 60 to be B, and 61 to be C. Now what we'll have to prove is that C square equals to A square plus B square, means the largest number square equals to the addition of smaller two numbers. So what we'll do is, first we'll find the square of 61, which is the largest number, so it equals to 3721. Now we'll find the addition of squares of these two numbers. So we'll take a square plus b square, which equals to 11 square plus 60 square. Now 11 square equals to 121 and 60 square equals to 3600, and 3600 plus 121 is nothing but 3721, and from 1 and 2 we get that c square equals to a square plus b square, means that was also 3721, and a square plus b square is also 3721. Therefore c square equals to a square plus b square. Therefore the given triplet is a Pythagorean triplet. By this procedure or this chronology you can prove this. Now we are going to see the property of 30, 60, 90 degree triangle. You will be having this as a part of your lesson, and this will be also used in order to solve the questions in the upcoming practice sets of 2.1, 2.2, etc. So let us see. So property of 30, 60, 90 degree triangle is used if the angles of a triangle are 30, 60 and 90 degree. Then the see what the condition says. The condition says that if the angles of a triangle are 30 degree, 60 degree and 90 degree respectively, then the side opposite to 30 degrees is half the hypotenuse, and the side opposite to 60 degrees root 3 upon 2 times the hypotenuse, which means that side opposite to 30 degree means AB. See here it is 30 degree. Now side opposite to 30 degree is AB. AB equals to 1 upon 2 into hypotenuse. Hypotenuse is AC, therefore AB equals to 1 upon 2 AC. Now side opposite to 60 degree equals to root 3 upon 2 into hypotenuse. So side opposite to 60 degree is BC. See, this is 60 degree, side opposite to 60 degree is BC. BC equals to root 3 upon 2 into hypotenuse. Now that was of 30, 60, 90 degree triangle. Now we'll see the property of 45, 45, 90 degree triangle. So it says that if the angles of a triangle are 45, 45 and 90 degree, then each of the perpendicular side is 1 upon root times the hypotenuse. It means that, see, if in any triangle this side is 90 degree, this one is 45 and this one is 45 degree, then BC equals to 1 upon root 2 times AC, and AB equals to 1 upon root 2 times AC. You can learn this if you know the Pythagoras, I'll not call it Pythagoras, the trigonometric table of sine. It will help you out in order to learn this, all types of formulas. Now we are going to learn the theorem of similarity of right angle triangle. So theorem of similarity of right angle triangles is that in the right angle triangle, if the altitude, this line BD is known as altitude, the altitude is drawn to the hypotenuse, then two triangles are formed. Then the two triangles formed are similar to the original triangle and to each other. It means that, see, if we draw an altitude from this point till the hypotenuse means BD, then this triangle and this triangle both are similar to each other, but these both triangles are also similar to the bigger triangle. This is the thing which they want to say by the theorem of similarity of right angle triangle. Now let us learn the theorem of geometric mean. Basically theorem of geometric mean is very easy and you will be able to learn this in a very easy manner. So theorem of geometric mean says that in a right angle triangle, see, this is a right angle triangle, the perpendicular segment to the hypotenuse from the opposite vertex, this is the opposite vertex, is the geometric mean of the segment into which hypotenuse is divided. So this is the geometric mean into which the hypotenuse is divided. So now there's a formula related to this. It says that in triangle ABC, what? In triangle ABC, measure angle B equals to 90 degree. We all know because it is a right angle triangle. Therefore, and we also know that a segment is drawn, so BD is perpendicular to AC. Now the formula says that BD square means twice this BD square equals to AD into DC. You saw BD square means BD into BD square equals to AD into AC. Now let us see the Apollonius theorem. Now personally saying, I would say that Apollonius theorem was the easiest and the most easiest formula I have learnt in geometry, Pythagoras theorem. It says that, see, this is a triangle ABC. It does not consider you to have a right angle triangle. There's a triangle ABC and AD is the median drawn. Now BD equals to DC. This is also given. So our formula, AB square plus AC square. You see, first this slope, then this slope. AB square plus AC square equals to 2 twice AD square plus twice DC square, or also you can take BD square, but I have taken DC square as both the measure is same. So again see, first this side slide, then this side slide, then this side, and then this or this, or whichever you want. So AB square plus AC square equals to twice AD square plus twice DC square. So friends, that is it for today. In the next lecture we are going to start with the questions related to this topic, Pythagoras theorem. Hope you will understand, hope you understood this lecture and the basics of Pythagoras theorem. This chapter 2 will be covered very easily. So that is it for today, guys. Thanks for watching. Like the video, share with your family and friends, and also subscribe to our channel. You can also comment below us the questions you want us to solve. We will solve your questions. Thanks for watching, and bye bye.